In this video, we'll talk a little bit about the behind the scenes of how actually Python runs the program that you write, and specifically we'll talk about the difference between compiled and interpreted languages. So there's a general trade-off. We want our computer programs to be as close to natural language as we can get, and computers want the nitty-gritty. They want step by step, down to ones and zeros, saying how to do what we're asking them to do. And so early days, we're pretty close to having a machine-readable format. And one such way to do that is getting to the assembly language. Assembly language is very low level. You're telling it, grab this variable, move it here, move it there, do this operation on it, and go. Now this actually gets close to the machine-readable data, and so, but this is very hard to work with. So programming languages have become more high level. And one such type of programming language, like C and C++, is a compiled language. Here's a C program that prints hello world. It's more readable. The next step you do is you run your program through a compiler linker. This looks at the entire program, figures out how to turn it into something that the computer can run, and it does it. And it makes an executable code, something that is very specific to that machine that you compiled it on, that operating system. So the joke is that when you have to wait till something compiles. So if you have a big program, it takes a while to compile. And hence the excuse that my code's compiling. Python, on the other hand, is leaning more towards the interpreted language, which means that there's not a compiler that looks to the entire program and puts everything together. Python code goes essentially line by line and figures out what to do and then runs that line. Now, as usual, it's a bit more complicated than that, because what actually happens is that the Python code gets interpreted, but it's actually turned into bytecode, which is an intermediate format. That means that the interpreter can be a little smarter, bytecode can get half the work done, but then that is run on a Python virtual machine. Java is much like this, where the code is compiled into bytecode, which can run on a virtual machine, and that's what's being run. Interesting enough, you can even see a little bit into the bytecode. Here's something in Python which adds up some numbers, and here is essentially disassembled bytecode, which shows just how detailed it has to be to do something very simple. Before I get into this, let me go and show you another benefit of the having something interpreted. Here's a program that runs in Python, and as I mentioned, Python will just go line by line and do what it's supposed to do. Let me run this to show you what this does. This is a cat and mouse. This is a little mouse running away from a cat. When the cat catches up, oh no, is the mouse going to get away? Okay, wait, we're doing a video. So it never took the entire program and compiled it, which is a nice thing. For example, if I wanted to start the cat someplace else, I can set some new values and run it right away. I don't need to wait till it compiles. That's really powerful. You can also do things like set debugging statements and run through it. Like right now, it'll stop every time it hits this line, and I can debug the program that way. So it's faster for us to write programs. Let me go open up a Python console. You can even run commands line at a time. And I just assigned my name into a string, and I can, let's say, find the length of the string. 13 characters in it, or pull out some characters from the string. Let's say the first 5 characters. So I'm actually running Python statements, and I can see what the effect is. So if I'm not really sure how things work, like let's say I'm not really sure how mod works, modulo operations work with negative numbers, I can just play around and see. I can just try it. I tried -4, mod 3, and I can see it. Unfortunately, CodeHS, the way that we're going to be using the programming in this class doesn't have a Python console, which is a sad thing in my view, because this makes it really nice to be able to just try things out. The reason you can do this is Python's interpreted. Python can look at that, know what to do. So let me tell you some other benefits of each type. C and C++ are fast, and they can be fast because the compiler can optimize code, and everything's all done, ready for the computer to run it. It also takes your code, and since it compiles it into an executable and links it into an executable, the users don't get to see the code, they just get to see the program, so your trade secrets are there. Interpreted languages can often be more portable. I can give anyone that Python program, you can run it no matter what computer you're on, Mac, Windows, Linux, whatever, as long as there's interpreted. Same thing with Java. Java can go just about anywhere that there's you can get a Java virtual machine on. And as I showed, it's easy to change your programs on the fly. So this kind of gives a high-end summary, and again, there are a lot of details that I'm kind of glossing over, but this is a really important point about why Python is so friendly to work with. And one more even complication is that often Python runs different modules that are written in C and C++, so you get both the benefit of interpreted language with the speed of a compiled language. Anyway, that's it for some of the differences between compiled and interpreted programming languages.